Hello everyone and welcome. Today I'm presenting a strategic comparison between containers and virtual machines. So in the slide one, as we see, containers offer lightweight execution, faster boot times, and excellent support for microservices. Virtual machines, on the other hand, provide a stronger isolation and full operation system flexibility. These presentations this presentation explores the key trade-off between these two approaches and cloud infrastructure. Okay, for the second slide, uh, for the second slide, this slide introduces the core architectural difference. Containers share the host kernel, which makes them lightweight and efficient. Virtual machines require a full operating system for each instance running on top of hypervisor. So this architectural split explains most of the performance, density, and security differences that we will see later. Okay, so for the tree, okay, we see here the cloud infrastructure evolved from manual bare metal provisioning to virtual machines, and then to containerization with the Docker. Today, Kubernetes provides orchestration and automation at a massive scale. So each phase reduced deployment time and increased efficiency, allowing modern DevOps and continuous delivery spaces. Okay, for the slide 4. So this slide outlines the models used in our analysis. We evaluate containers and the virtual machines across architecture, security trait vectors, performance benchmarks, and how can I say, okay, reliability patterns, orchestration tooling, and hybrid models. So the goal is to provide a complete and data-driven understanding of when each technology should be used. Okay, for uh, for slide 5. Sorry, for slide 5. Here we see the difference between type 1 and type 2 hypervisors. So type 1 hypervisor run directly on hardware and offer better performance and security. Type 2 hypervisors run on a host operating system and introduce more overhead. Both models use central processor unit, memory, and input-output virtualization, which is why VMS, which means how virtual machines, are heavier than containers. Okay, slide 6. For the slide 6, this slide compares kernel isolation. Containers use namespace isolation and C groups, sharing the host kernel. So this makes them extremely fast to start. Okay, but for virtual machines, provide a full hardware and kernel isolation, which increases overhead but offers stronger security boundaries. Choosing between them depends on the use case. Okay, for the slide 7, the slide explains containers runtime models. Standard runtimes like Docker use a pure namespace isolation, making them lightweight but less secure. So, lightweight virtual machine based runtimes such as kata containers combine container speed with virtual machine level isolation, so the runtime choice directly affects the security and performance of the environment. For the 8, as we see, containers have a significantly significantly lower overhead, start in seconds or even milliseconds, and offer high density, many more workloads per host. Okay, so for the virtual machines start slower and consume more resources, but they offer mature live migration capabilities and strong isolation. So each has advantage depending on operational uh, priorities. Priorities. Okay, so now we're going to slide 9. For the slide 9, this slide compares the attack surface. Containers depend on many large components such as Linux kernel, Docker daemon, and Kubernetes APA, which increases exposure. Okay, for the virtual machines, really mainly on the hypervisor with a much smaller code base, fewer components mean fewer vulnerabilities and reduced risk. Okay, slide 10. For the slide 10, this slide highlights a major container escape vulnerabilities. For example, run C override allows attackers to replace the runtime binary. Dirty COW explodes memory copy on write. And cap sysadmin measures grants excessive privileges. Okay, so these vulnerabilities demonstrate that containers require a strong hardening and careful privilege management. Okay, now for the slide 11. This slide compares the security risk profiles. Containers escapes are more frequent because they depend heavily on kernel configuration, and virtual machine escapes are extremely rare but very severe when they occur. For high risk sensitive workloads, organizations often choose virtual machines for a stronger isolation. So my colleagues will continue our presentation.
Thanks, Salah. Hey, my name is Yunus. I will take us through how contains and VMS compare directly, plus some real world cases. This is slide 12. The key Docker for building and running containers and Kubernetes for outstarting scale in the cloud. Think Amazon ECS, Google or other content ensure for managed service. Resource-wise contains when for efficiency, VMS might eat 10 to 12%, 10 to 20% overhead per instance due to multiple OCS. Contain share the kernel, so you can run 100 on one service if C doesn't VMS. Uh, Startup Startup contains both in second, perfect for auto scales. VMS take a minute to load the full OS clouds. This means contains respond faster to traffic spikes. uh, Insulation. Insulation FMS. Hardware level separation via hypervision, making them more secure. Workload contains OS level insulation, which is lighter but riskier without proper config. Portability contains shine here, build once, run anywhere. As the kernel matches the matches VMS are portable to Blacker move due size. Both work well multi cloud setup. Slide 17. Scalability contains scale with ease, spinning up instantly, VMS scale better, adding resource to one, but are slow for massive carbonates. Make the container scaling automated. Security VMS have better build insulation, reducing blast and breach. Need tools like SL Linux, like Linux, or scanning in could both benefit for provide security groups. Uh, VMS is SQL running legacy app that need specific OSIS, high security environment like finance or testing multiple OS configs. Thanks monolith app or virtual desktop. That's 20. Container for Microsoft Service slash CD pipeline or code native apps. Great developing frequently like web service or AI model. Often they combine running contains inside VMS for adding installation. My could setup do this VMS as host. Contain for apps, balance efficiency and security. In cloud VMS, they are developed via instance like IC. You provision install OS and manage good for control, but more hand on. Thank you for the following. I will leave you to my friend to complete this presentation. Thank you for listening.
Hello, my name is Mustafa Ashraf. Okay, let's continue after my friend Yunus. I will continue with the slide 23, cloud deployment. Cloud deployment containers in cloud. Containers in the cloud use services like EKS or AKS. You upload containers images to a registry and use Kubernetes to image them. This reduces hardware work and lets you focus more on applications. Slide 24, cost comparison. The cost conversion. Containers are cheaper because they use hardware efficiently and can run many apps on the same machine. VMs cost more but gives stable and predictable billing. In cloud containers are better for flexible or changing workloads. Slide 25 performance benchmarks. Containers use 50 to 70% less CPU and memory than VMs for most tasks, but VMs are better for heavy I/O tasks like database and storage operations because they don't share resources. Slide 26, migration strategies to move VMs. You just lift and shift them to cloud machines. For containerize, for containers, you containerize apps using Docker and manage them with Kubernetes. Tools like Migrate for Kubernetes help with the process. 27 future trends in VMs. VMs are evolving with serverless VM options, improved support for AI workloads, and use in edge computing to reduce delay latency. 28 future trends in containers. Containers will include web assembly for faster and flexible use, better security with confidential computing, and deeper cloud native adoption in campaigns. 29 which to choose. Use VMs when you need strong isolation, security, or to run old systems. Use containers when you need speed, scaling, and flexibility. Sometimes you use both in a hybrid approach based on your needs. Okay, 30 and the last one. There is two cases. Case study one: Netflix uses containers with Titus on AWS to run microservice. This helps them scale easily and serve millions of users smoothly. Case study 2: a bank uses VMs to run secure and sensitive apps because of complaints compliance, but they use containers for development tools to get speed and flexibility. Thank you for listening. This is the last thing about this presentation. Thank you.